Ladies and gentlemen, today we are talking about the areas of triangles and parallelograms, which you all have seen before and have come to know and love in your middle school experience. Let's talk first of all about the most simple of shapes, but yet one of the most beautiful of shapes because of so many cool properties we've talked about, rectangles. Area of a rectangle is the product of its base and its height. So you multiply a base times your height, that's the area of your rectangle. Remember that area is just this two-dimensional space that is inside a shape, or that a shape takes up. So all the space inside here is the area that it's taking up. Now, you can call this length and width or base and height, but we're going to stick with base and height for all the types of shapes we're dealing with. So that's the basic one. To find the perimeter of your rectangle, we've covered that before. You just add all of your sides together. We covered that. Chapter 1, a long time ago. It seems like ancient history. Now, if we look at this rectangle, I'm going to call my base, let's just say this is 12 units wide and 5 units high. So my area is 60 square units. We always use square units for area. Let's say that this is just like some pile of books or something taking up a certain amount of area. If I take that pile of books and just kind of lean it over, the height hasn't changed, it's still 5. The base hasn't changed, it's still 12. And my area hasn't changed. It's just become slanted. The shape has changed, the area hasn't, our books have not grown or shrunk, our area is still considered the same. That's why we also say that the area formula of a parallelogram is still base times height. It's just a rectangle that's crooked. It's still the same type of formula we use for a rectangle. If you don't believe me, take a look at this rectangle, this blue area. If I were to turn this blue area into a parallelogram, the area has not changed, even though my shape has changed. It's just been rearranged. So the formula won't change. It's still base times height. Any type of parallelogram, whether it's a rectangle, a rhombus, a square, regular parallelogram, rectangle, it's always base times height. And what's interesting about parallelograms is if you cut this in half of it is a triangle. So half of a parallelogram is a triangle. That's why the area of a triangle isn't base times height, it's half base times height because it's half of a parallelogram. So that's where that 1/2 comes from in the area of a triangle. If you're not finished copying these down, then pause it, otherwise I'm going to move on. So, find the area of parallelogram PQRS. Well, there's a few different ways we can look at it. One is we can look at, let me write it here, our base and our height, as our base being 6. And our height is not 12. We don't measure height diagonally. We measure it perpendicular to the ground, or perpendicular to the base. If I try to draw a line inside that's perpendicular to the base, it doesn't reach the other one. So it's not really the full height. That's a problem. So in that case, what we usually do is draw a height somewhere out here. So I'm going to draw a height going down to where my base is at and bringing it over. And it's perpendicular. So my height here is going to be 8. So that means my area is 48 square units. Kind of funny to see a height drawn outside the figure instead of inside, but it's still considered a proper height. A second way you might have looked at this is you might have chose to use 12 as your base and 4 as your height. So if you kind of reoriented this and flipped it around, you had your 12s here, your 6s here, and your 4 on the inside here, it's more easy to see that 12 is your base and 4 is your height. So for the second case, you could say the area is 12 times 4, which is still 48 square units. Sometimes a drawing might not look as complicated as this one, but just so you know, you may see a height drawn inside or drawn outside. Either way, it should just be perpendicular to whatever base that you have. Let's do some more examples here. Let's do these 3 very quickly. Find the perimeter and area. So for number 1, perimeter, you just add all of your sides together. So the perimeter is 10 plus 21 plus 17, which I want to say is 48. Yes, 48. Units, not squared, but just units. Your area of a triangle is given by the formula 1/2 times the base times the height. Well, the base here is 21 because it's perpendicular to your height, which is 8. And if you multiply these, your area is 84 square units. Let's move on to number 2. We know this is a parallelogram because opposite sides are parallel, which means opposite sides are also the same or congruent. They have the same length. So the perimeter is 20 plus 20 plus 30 plus the 30, which is 40 plus 60, which is 100 units. The area of a parallelogram is just the base times the height. Well, the height we can see is 17. And the base is whatever is perpendicular to the height, which is our 30. So 17 times 30. And if we take 17 and multiply that times 30, give me 1 second here. Should be 510 square units. Can I possibly? No, it's not going to work. I'm going to go ahead and erase this one. Looking at number 3. If we were to find the perimeter of this triangle, that's a difficult thing because we're missing the sides. We can call that x. Now you can use your Pythagorean theorem to find x, or you can just say, well, x is 12 because this is a triple, a 5, 12, 13 triple, so this has to be 12. That being said, your perimeter is 12 plus 13 plus 5, which is 30 units. Your area is 1/2 times the base times the height. Well, the base and height are always perpendicular, so it has to be 12 and 5. Which, and this is just a coincidence, is also 30. This time it's units squared. There are some great challenging problems we can look at regarding area, perimeter, etc. So I'm just going to do a couple of them, if this video will permit. So the base of a triangle is twice its height. Area of a triangle is 36. Find the base and the height. We know our area formula is 1/2 times the base times the height. So let's just plug in what we know. We know the area is 36. We cannot solve this equation. We have 2 variables. Too many options here. But here's what we do know. The base is twice its height. So whatever the base is, it's 2 times the height. So instead of using base, I'm going to substitute in 2 times the height. So instead of base, I'm using 2 times the height because that's the relationship. So now I can write this equation with 1 variable. Because again, we can't solve an equation with 2 variables. We have to just narrow it down to 1. And using some algebra to simplify the right side, well, 1/2 of 2 is just 1. 1/2 times 2 is 1. So these will actually cancel. Then I just have h times h, which is h to the 2nd power. And to get rid of a square, I square root both sides. So h is the positive version, which is 6, because we're talking about length. So the height is 6, so the base is 2 times 6, which is 12, and voila. You can check your answer because 1/2 times the base, which is 12, times the height, which is 6, should equal 36. And if you multiply this, it does equal 36 square units, so it does check out. Let's do one last problem, I think. This is something that connects geometry to everybody's life, even if you don't have a career path that involves geometry every day. If you plan on owning a home, you'll have to paint at some point, put in new flooring at some point, maybe drywall at some point, so you'll end up needing to know something about area. This problem states you need to buy paint so you can paint the side of a barn. You may never own a barn, but you will maybe own a house, so it can still apply. A gallon of paint covers 350 square feet. How many gallons should you buy? We have to find out how many square feet to know how many gallons. And if we're finding square feet, that means we're finding area. So let's find the area of this side of the barn. Well, this is kind of an awkward shape. It's pentagon, so we can't really find the area of the pentagon. We don't know that yet. But we can break it apart into a rectangle and a triangle, which we can do. So first, with the rectangle, the area is the base times the height, which is 26 times 18. And if you multiply 26 times 18, we have 468, and that's square feet. And now we need to find the area of our triangle, and then we can add them together. That's the area of the whole side. Well, for the triangle, we know it's an isosceles triangle, and it's also a right triangle. So we could use 45, 45, 90 here. Or we could drop a height and altitude, and since, clear this up, since this is 45, ooh, that looks horrible. And this is 90, this should be 45. And so since we cut this in half and both of these are 13, this should be 13 as well. You could do something like that. I'm not going to do that. Instead, I'm going to use my generic 45, 45, 90 here. So if this whole thing is 26, this is 26 over root 2, as is this. You also could use Pythagorean theorem. Lots of options here. And call these both x. Maybe that's the one that I'll write out. So x squared plus x squared equals 26 squared. So 26 squared equals 2 times x squared. Just combining like terms here. And 26 to the second power is 676. I can divide both sides by 2. 676 equals x squared. I'm sorry, that should be, I divided by 2, that should be 338, my fault. And so I have 338 equals x squared. If I take the square root of 338, hopefully it comes up with a nice number. No, it doesn't, so I'll just leave it as the square root of 338. But we're not done. We need to find the area. Since these two sides are perpendicular to each other, that's our base and our height. So the area of the triangle is 1/2 times the base times the height. Well, the root 38 times root 38 is just whole number 338. And if you divide 338 by 2, which is the same as multiplying it times 1/2, this is 169 square feet for your triangle. So we know that the rectangle is 468, the triangle is 169, so that means that the total area, when we add those together, is 637. Okay, now we can answer the question. How many gallons do we need? Well, 1 gallon is 350 square feet, so this needs more than a gallon. So we'll say, well, we have 637 square feet. The question is, how many 350s go into that? What's 637 divided by 350? How many gallons or how many sets of 350 go into 637? So 637 divided by 350 gives us a result of 1.82 gallons. But you can't buy gallons. You can't buy 0.82 of a gallon, so we round it up to 2 gallons. That's how much you need. You have a little extra, but that happens in real life. Things aren't always nice when they work out. So there's a brief overview of this area. There's lots of other challenging problems we can go through that we'll see in class. These are the basics just to get you started.